Okay, we're looking at factored form and x-intercepts, section 10.5, if you wanted to title your notes. Okay, so we have the area. If you remember the algebra tiles, there's two ways to look at the area of this. You could look at it with just the colors. If you remember, each blue one was x squared. So area could either be x squared, and then each of these guys was x. Okay. Or you could think of it as, like this whole thing is a rectangle. So we could do length times width. The width of my rectangle, so from here to here, is x. From here to here, also x. Here and here is each 1 and 1. So you could do area, sorry about my pen, okay, is x times x plus 2. Okay, these two are interchangeable because if you did the distributive property, x times x is x squared, and 2 times x is 2x. So they're interchangeable. It just depends how you want to look at it. So in this one, our area would either be x squared minus 3x. Remember, color matters. Okay, or we could do length times width. So x times x, and these are minus ones. So x times x minus 3. Okay, and again, they're interchangeable if we did the distributive property. All right, one more. I got two blue ones. So that'd be 2x squared plus 1, 2, 3, 4x. Or length times width, I got 2x for my width, and then x plus 2. Let's do this, x plus 2. So again, if I distribute this through, I get the same thing. Okay, so without the algebra tiles, we can just take x times x is x squared, and then 5 times x is 5x. Okay, so we're just looking at distributive property, basically. And then we have our powers. So like in this one, we'd have 3x times x would be 3x squared, and then 3x times 2, of course, would be 6x. Okay, x times x, and 7 times x. Watch your signs. This would be negative 20x squared, and then this would be plus 12x. Ugh, sorry, it's not any better. Okay. Then we could do factoring. Okay, so we're going to reverse that. So expanding is we're going to get rid of the parentheses. We're going to kind of simplify like we've done before. Factoring is the reverse. So I'm going to go from this to this. So I have to think, all right, well, what numbers can come out of 20 and 12? The biggest number I can take out would be 4. What can I take out of x squared and x? Okay, so a couple ways to look at that. For x squared and 7x, okay, this is a 1, so the biggest thing I can take out is a 1. For my x's, I have an x squared and I have an x. That means I can take out an x, okay, and I'd be left with another x and a minus and a 7. Okay, so now reverse that. X times x would be x squared, x times 7 would be 7x. So these are interchangeable, but it's a little trickier to go from here to here for the factoring. Another way to look at that is if you remember when you factored in middle school, x squared means x times x, and 7x means 7 times x. Well, what do you have in common? We have an x in common. That's what goes on the outside, right? No, I suppose I should do this because it was a negative 7. And these two are different, so then I just take my x minus 7, this part here, and I'm going to put that right there. It's another way to look at it. Okay, whenever you can take a negative out, take it out. So let's take that negative x out. I still have an x left. And a negative, okay, what am I going to do here? Well, this would have to be a negative, because a negative times a negative would be a positive. And again, if you just want to check yourself, just distribute and see if you get the same answer again. Okay? Again, biggest thing I can take out is an x, and then I have x plus 11 left. Sorry about that. All right, now we got a 4 and a 20. Well, I can take out a 1, I can take out a 2, and I can take out a 4. So we want to take out the biggest number we can, which is a 4. All right, then I look at my x squareds and my x, I can take out an x. All right, if I divide this by this, I still have an x left. I got my minus, and this divided by this would just be 5. Okay, monomial versus binomial. A monomial is a number, a variable, or the product of a number and one or more variables. Like x is a monomial. 2x squared y is a monomial. Negative 3x cubed y to the 4th z. Still a monomial. Okay? Binomial is the sum of two monomials. So if I add two of these together, now it's a binomial. Could be as simple as x plus 2. Okay? So if we had to identify these, this would be a monomial, binomial, monomial, binomial, monomial, binomial, binomial, monomial. So you just need to be able to identify them at this point. So these are all the same, okay, because they're all multiplying basically. And these are all the same because we have two monomials separated by either an addition sign or a subtraction sign. Okay, so how does that apply to what we're doing? Well, we've got to factor one side completely, okay? Well, obviously this side is factored, so we have to factor that side. So I can take out an x, and I'm left with x minus 3. Okay? And then we want to do b, which says find the x-intercepts and the y-intercept of the graph. Okay, we've done this, all right? Here, let me put a parenthesis on there. This is where we split it. So you set 0 in for y. Okay? And then remember we split it. So we said either x has to equal 0, that's one of them, or x minus 3 has to equal 0. So x-intercept would be 3. So I have 0, 0, and I have 3, 0. Okay? Then you put 0 in for x right here. So 0 times 0 minus 3. So that'd be negative 3 times 0 is 0. So y would be 0. So my x-intercept is 0, 0. That's the gist of it. Here's your x-intercepts. Here's your y-intercept. I mean, we could do a bunch more like this, but really they're all kind of the same. Let's do this one. A little tougher factoring. So you got negative 5x times x minus 4. Split it. Okay, so either negative 5x equals 0 or x minus 4 equals 0. Divide by negative 5, divide by negative 5, so I get x equals 0. So 0, 0. Or I add 4, x equals 4. So 4, 0. And then if I put 0 in for x, negative 5 times 0, 0 minus 4, so again, negative 5 times 0, 0 minus 4, 0 times 0 is 0, so y equals 0, so again, 0, 0. Okay?